Hello everyone, welcome again to my channel. Today we will be discussing about the lessons on quarter 4 week 2 of Mathematics 10. Here are our objectives. Number 1, identify the specific measures of position, example, percentile, decile, quartile. And number 2, calculate the specific measures of position, example, percentile, decile, quartile. But before we proceed to our discussion, let us have first a review on our previous lesson on quartile, decile, and percentile. Remember that the third quartile is also the same as the value of the 75th percentile. When you have the second quartile, that is the same with 5th decile or the 50th percentile. That is also our median. And the first quartile is the same as the 25th percentile. If we have first decile, that's equivalent to the 10th percentile, or if that's 9th decile, that is the 90th percentile. Looking on this table, we refer this as the frequency distribution table. And we will be dealing with different terms like class limits, class frequency, class boundaries, class width, and class mark. Let us define class limits. Class limits, they are values that can fall in a given class interval. So if we have here on our example 5, 13, 21, 29, and so on, we refer the smallest values as the lower class limits. And we have here 12, 20, 28, and so on. We refer these largest values as the upper class limit. Class frequency. Class frequency is the second column on our table that refers to the number of observations falling in a particular class. So example, on our class here 5 to 12, its frequency is 8. The class 13 to 20, the frequency is 9, and so on. Class boundaries. There are values halfway between the upper class limit of one class and the lower class limit of the next class. So in our example here, we have here the upper class limit, which is 12, and the lower class limit of the next class is 13. Halfway of that is 12.5. So if we're going to have this, our class boundaries is 4.5 to 12.5, 12.5 to 20.5, 20.5 to 28.5, and so on. We just simply subtract 0.5 to our lower class limit and add 0.5 to our upper class limit. Class width. There are numerical difference between the upper and lower boundaries of any class. So say for example, if we have here 5 and 13, 13 minus 5, that's 8. Or 20 minus 12, that's also 8. So that's the class width. Class mark. This is the midpoint between the given class interval. So, if we have the class 70 to 74, 72 is the midpoint between 70 and 74. Or that is also the average of the upper limit and the lower limit of a class. So, say for example, if we have 70 here as the lower limit, 74 as the upper limit, 70 plus 74, that's 144, divided by 2, so that is 72. Here is a formula in case we're going to compute the percentile of a group data. P sub k is equal to L sub p plus C multiplied by nk over 100 minus F sub b all over F sub b. Let us have the meaning of each symbols given in the formula. LP is the lower class boundary of the pk class or the percentile class. C is the class size. N is the total number of observations. K is the percentile of interest. F sub b is less than cumulative frequency before the pk class. F sub p is the frequency of the pk class. How are we going to use this formula in computing the percentile of a group data? Let us have an example. Given this problem, Consider the scores of 120 grade 10 students in the third quarter math examination. Find the 30th percentile of the distribution. So are we going to find the 30th percentile of the distribution? First, you are going to create a 4-column table. On our given problem, the first and second column is already given. So we're just going to complete the third and the fourth column. But the question is, how are we going to complete the third and fourth columns? Before that, let us find first the total number of class observations. So under the second column, add up all the given frequency here in each class. So you will be having now the value of n, which stands for the class observations, and that is 120. To complete for the third column, you are just going to observe the lower class limit in each class, and you're just going to simply subtract 0.5 for each given value under lower class limit. So 1 minus 0.5, the answer will be 0.5, and you are going to place that under third column. 11 minus 0.5, the result is 10.5. 21 minus 0.5, the result is 20.5, and so on. So you have already completed the third column or the lower class boundaries. Now let's proceed to the last column under cumulative frequency. How are we going to complete the table? First, we're going to focus on the lowest class of the given distribution and its given frequency. That frequency will be the first number to be written under the first row of the column cumulative frequency. To find the next value in that column, you are just going to add the frequency of the next class, which is 18. So 4 plus 18, that is equal to 22. Then, add again to the next frequency of the next class, 22 plus 21, that is equal to 43. Continue the same process. The next value will be 92, 113, and 120. Take note, the last number should be the value which is equal to the total frequency or the number of class observation. Now we have already completed the table, so our next step is we're going to compute for nk over 100. Again, n is the total frequency, and that is equal to 120. And k is equal to 30 because we are asked to find the 30th percentile of the given distribution. So by substitution, nk over 100 is equal to 120 times 30 all over 100, and that is equal to 36. By this, we can locate the 30th percentile class. Now let us compare the computed value for nk over 100, which is equal to 36, to the values under cumulative frequency. Which of these values is equal to 36 or exceeds 36 for the first time? And that is 43. So we have our 30th percentile class with an interval of 21 to 30 with frequency 21 and 20.5 for the lower class boundary. Let us use our formula now in finding the 30th percentile. That is equal to P sub k is equal to L sub P plus C multiplied by nk over 100 minus F sub B all over F sub P. Let us find the value of L sub P or the lower class boundary of the 30th percentile class, and that is 20.5. So L sub P is 20.5. Next symbol is C or the class width. We can obtain that by subtracting our lower class limits or the upper class limits. 11 minus 1 or 20 minus 10, and that is equal to 10. So our value of C is equal to 10. Next is nk over 100. We have computed it a while ago, and that is equal to 36. The next symbol, F sub B, that is our less than cumulative frequency. But where can we find that? if we have 43 as the value for the cumulative frequency here of the 30th percentile class, that is not the value for f sub b. We are going to get the value before 43. That is 22. So our less than cumulative frequency of the 30th percentile class is 22, or f sub b is equal to 22. The last symbol is f sub b, or that is the frequency of the percentile class, and that is equal to 21. So f sub b is equal to 21. Substituting all these values to our given formula, that will be equal to p sub 30 is equal to 20.5 plus 10 times the difference of 36 and 22 over 21. Using our calculator to find p sub 30, this is equal to 27.17. So, the 30th percentile of the set of data is 27.17. And if we're going to interpret this value, this means 30% of all data points are below or less than 27.17. So those are our steps in computing the percentile of group data. How about computing the decile of a group data? We will be using the same formula. The only difference is that instead of P, we will be using D. That stands for decile. And instead of NK over 100, that will be NK over 10 for decile. Again, LD is the lower class boundary of the decile class. C is the class size or the class width. N is the total number of observations. K is the decile of interest. F sub B is less than cumulative frequency before the decile class. And F sub D is the frequency of the decile class. Let us have an example. Consider the scores of 120 grade 10 students in the third quarter math examination. Find the 7th decile of the distribution. So just like what we have done a while ago, we completed the table. And after that, we're going to compute now for NK over 10. So again, our N is 120. K is 7 because we're asked to find the 7th decile of the distribution. So by substitution, the result is 84. Again, let us compare the computed value for NK over 10 to the values under cumulative frequency. Which of this value is equal to 84 or exceeds 84 for the first time? And that is 92. So from this, we can identify the 7th decile class. So that is 31 to 40 with a frequency of 49 and a lower class boundary which is 30.5. Let us now use our formula in finding decile for a group data. Let's find the value of each symbol in the given formula. So LD, or the lower class boundary for the 7th decile class, is 30.5. C, that is our class size, that's 10. And then NK over 100, which we have computed a while ago, 84. Then the frequency before the decile class, so that's 43. And then the frequency of the decile class is 49. Then let's substitute all these values to the given formula. We will be arriving at 38.87. This means the 7th decile of this set of data is 38.87. And this also means that 70% of all data points are below or less than 38.87. So this is our process in computing for the decile of a group data. How about computing the quartile of a group data? Here is our formula in finding the quartile of a group data. And instead of B or D, this time we'll having Q, that stands for quartile. And instead of NK over 100 or NK over 10, for quartile of group data, that's NK over 4. This time, we will be having L sub Q, that stands for the lower boundary of the quartile class. C is again the class size. N is again the total number of observation. K is the quartile of interest. F sub B is the less than commutative frequency before the quartile class. F sub Q is the frequency of the quartile class. So let's have the same problem, but this time we will be computing for the first quartile of the distribution. Again, you have to complete that 4-column table. And then for quartile, we will be computing for NK over 4. And since N is equal to 120, this time K is equal to 1 because we are asked to find the first quartile of the given distribution. By substitution, that will be 120 times 1 all over 4, and that is equal to 30. Then compare the computed value again, which is 30, to the values under commutative frequency, which among these values is equal to 30 or exceeds 30 for the first time, and that is 43. Therefore, we can find the first quartile class, and that is 21 to 30 with a frequency of 21 and the lower class boundaries of 20.5. Given our formula for quartile, let's find the values for each symbols given in the formula. For our lower class boundary, that's 20.5, and then the class size is again 10, and K over 4 based on our computation a while ago, which is 30. Then the less than commutative frequency before the first quartile class, that's 22, and the frequency of the quartile class is 21. Substitute all these values to our given formula, we will be arriving at the result of 24.31. This means that the first quartile of this set of data is 24.31, and also mean that 25% of all data points are below or less than 24.31. Thank you for watching and learning with me. See you on my next videos.